Let us talk about thermochemistry, that is the study which deals with the conversion of chemical energies. It is basically dealing based on the first law of thermodynamics. In this, the energy changes in chemical reaction, as we know, are mainly either due to the breaking up of existing bonds um, between the atoms, or it is due to the formation of new bonds, thus providing information. So let us consider a thermochemical equation in which that will give you information that during a reaction either heat is evolved or absorbed. So in this case, carbon, it burns in oxygen, giving you carbon dioxide. So it is releasing 393.5 kilojoules of heat per 1 mole of carbon dioxide. Now let us talk about Hess law. This law was given by Swiss-born Russian chemist G.H. Hess, and he is famous for his two fundamental laws of thermochemistry. First was the law of constant heat summation, and second was the law of thermoneutrality. Now, according to this law, if a reaction takes place in one step or many, the change in the enthalpy, it will remain same. Now let us consider this equation, which a reactant is getting converted into product. So either it can get converted directly, or it can take in various steps, like a reactant getting converted into intermediate and then to the product. Now let us consider this path as path A, this as B, and this as C. Now according to this reaction, according to this law, if a reaction takes place in one step or many, change in enthalpy will be same. That is, the heat change during path A, that will be equal to the heat change during path B plus C. A sign will put accordingly whether heat is absorbed or evolved. So thermodynamically, Hess law was justified because the enthalpy change, it is a state function, and it depends on the enthalpy difference in the initial and the final state, and not upon the manner how the final state has reached. So thus Hess law, it can be used in the determination of enthalpy of formation, in the determination of heat of transition, or in the calculation of enthalpies from a given data. Let us consider this example in which rhombic sulfur, that is getting converted into SO3 sulfur trioxide, and during that process this amount of heat is evolved. Now this can take place in a single step, or it can take place like this also, in which sulfur first getting converted into sulfur dioxide, and that is getting converted into sulfur trioxide. Now if you see this, let us say this is path A and this is B and C. So path A will be equivalent to path B plus C. So minus 297.5 plus minus 97.9, if you calculate it, you will get this. Now this is second example in which carbon reacts in presence of oxygen to give you carbon dioxide, and during that process this amount of energy is released. And second is carbon first forming carbon monoxide and then giving you carbon dioxide. So if you, this is path A, this is path B plus C. So path A will be equal to path B plus C. So if you calculate this two, you will get this. Now let us talk about the Kirchhoff's law. This law was given by Gustav Kirchhoff, and it tells you the relationship of variation of enthalpy of a reaction with the temperature. So at constant pressure, the change in enthalpy of reaction will equal to the change in heat capacity and the change in temperature. Let us consider following set of reaction in which a reactant A, which is at temperature T1, it will be getting converted into product B at same temperature T1, such that the pressure is maintained constant. Now this conversion will be carried out in two steps. Either there will be increase in the temperature and then it get converted into product, but according to Hess law, the total heat change must be same in both the cases. Now let us consider. First is when the reactant at state A at temperature T1 is getting converted to heated to temperature T2. So the heat which is absorbed, that will be dT Cpa, where dT is the change in the temperature, Cpa, where Cpa is the heat capacity of the reactant in state A at constant pressure. So the reaction is not allowed to take place at the temperature, and the heat change, it will follow the process Hb minus Ha is equal to H2. So total heat change, that will be equal to dT Cpa plus delta H1. The second is the reactant in state A first get converted into product at same temperature. So in that case the heat change will be Hb minus, that is H1. The temperature of the product is after that raised to T2. So heat absorbed will be given by delta T Cpb, where this is the heat capacity of the products. So total heat change will be given by this equation. Now according to Hess law, these two equations, they should be equal. So I'm writing these two equations, they are equal. Now taking enthalpy one side and this term other side. So you are getting delta H2 minus delta H1 is equal to delta Cp delta T, where Cp is Cpb minus Cpa, or delta H2 minus delta H1 oblique delta T, that will be delta Cp. So for a small change in temperature, it will be denoted by this. Similar you will do for a constant volume. In that case it will be dE upon dt delta Cv. So these two relationships, they are representing two forms of Kirchhoff's equation, and you can easily calculate the heat of reaction at a given temperature when the value is known at other temperature. So this was all about thermochemistry.